Hi everyone, welcome to Math World. This is Cambridge International AS and A-Level Mathematics Paper 3, which is a pure mathematics 3 for May-June 2021, and the code is 9709/33. So let's get started. Now, question number 1. Expand 1 plus 3x to the power of 2 over 3 in ascending powers of x up to and including the term in x cubed, simplifying the coefficients. So now for this question, since the power of the function is a rational number, okay, or is a quotient, that means I would have to use this formula 1 plus x to the power of n. Then according to this binomial expansion, it will be 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 over 3 factorial x cubed. Okay, because we need to get the expansion up to x cubed. So when you need to use this formula, make sure it is positive 1 and positive, and it is plus x. Okay, and it must be plus, so the x can be changed to any other multiple x. So now I will start copying the question, and when you compare, our x in the formula has been changed to 3x. That means you just need to change the x accordingly. Okay, so of course your n is 2 over 3, so it will be 1 plus nx, so 2 over 3x, then plus n is 2 over 3, then 2 over 3 minus 1, which is our n minus 1, you will be getting negative 1 over 3, then over 2 factorial. Now it is 3x squared, because your x has been changed to 3x, which means my second term should be 3x here. Okay, and then the fourth term will be 2 over 3, which is our n, then n minus 1. So 2 over 3 minus 1 is negative 1 over 3. Then after that, negative 1 over 3, you minus another 1, which is our n minus 2. Then I will be getting negative 4 over 3, then divided by 3 factorial, and then 3x cubed. Okay, then from here, when you simplify, 2 over 3 times 3x, it will be 2x, because the 2 and 1/3 can be cancelled off. Then the next term is going to be negative x squared, and the last term is 4 over 3x cubed. So this is the expansion up to x cubed. Okay, now question number 2. Solve the equation 4 to the power of x equals to 3 plus 4 to the power of negative x. Give your answer equal to 3 decimal places. So I will rewrite the question, and then I will let u be e power 4 power x. That means now the 4 to the power of negative x is basically 1 over 4 to the power of x, which means this is 1 over u. Then now my equation becomes u equals to 3 plus 1 over u. Okay, so from here I will multiply the whole equation by u, then you will be getting u squared equals to 3u plus 1, and by moving 3u plus 1 to the left side, okay, then you will be getting a quadratic equation in terms of u. So that will be u squared minus 3u minus 1 equals to 0. Now, my coefficients of u squared will be 1, which is my a, and then the b, which is the coefficient of u, is negative 3, and then the c is negative 1. So now, for your information, if let's say you are solving this quadratic equation, okay, then the x will be minus b plus minus square root of b squared minus 4ac over 2a. So I'm using this because I can't factorize this quadratic equation. Okay, so from here you will get u equals to minus b plus minus square root of b squared minus 4ac. So minus 3 squared minus 4, a is 1, c is minus 1, then over 2a. So from here, you will be getting 3 plus minus square root 13 divided by 2. Okay, and then you will be getting two u values that will be negative 0.302738 and another one is 3.30278. So here I give more decimal places first because that is the working. And then now after you found the u, okay, then we have to solve the equation in terms of x, right? That means you have to replace u by 4 power x. So from here, I will write 4 to the power of x is negative 0.30278 or 4 to the power of x is positive 3.30278. So these are the two values. But then we know that for the exponential, this is what is called as exponential function or power function. It cannot be negative because we have to take ln both sides. Alright, so just for information, the exponential graph always in this shape. So obviously, it is always above the x-axis, which means your y value should be positive. So that means this is no solution. Okay, therefore, we have to solve 4 to the power of x equals to 3.30278. So to solve this problem, we need to take ln both sides. So ln 4 power x equals to ln 3.30278. Therefore, now, according to the ln formula, okay, ln a to the power of b, it will be b ln a, which means now the x will be moved down. So I will get x ln 4 equals to ln of 3.30278. Hence, your x is the division of these two values. Okay, and now we need to give our answer correct to 3 decimal places. That means you will be getting 0.862. So that's the solution of this question. Okay, now the next question is question number 3. The parametric equations of the curve are x equals to t plus ln t plus 2 and y is t minus 1 multiplied with exponential negative 2t, whereby the t is greater than negative 2. A. Express dy dx in terms of t, simplifying your answer. So, to get the dy dx, we need to apply chain rule. So, chain rule is basically dy dx equals to dy over dt times dt over dx. You can use this, or probably you can just write dy over dt divided by dx over dt. So we have two formulas here. Okay, so now first of all, get the dx dt. So dx dt, differentiate t with respect to t is 1, and to differentiate the ln, okay, we have another formula here. Differentiate ln fx with respect to x, it will be always over fx, and the numerator is f prime x. So which means now I will get plus ln t plus 2. So it will be over t plus 2 first. Then the numerator is a differentiation of t plus 2, which means it's 1. Then from here, I need to get the same denominator, which is a t plus 2. So t plus 2 multiplied with 1, it will be t plus 2, then plus 1, the existing 1, then at last you will be getting t plus 3 over t plus 2. So this is our dx over dt. Okay, and now for the y. So for the y equals to t minus 1 multiplied with exponential negative 2t. So here you need to apply the products rule. Alright, so for products rule, d over dx uv, it will be uv prime plus vu prime. Okay, so that is the products rule, VU prime. Okay, so it means that now I have to let my U be t minus 1, then my U prime is 1 because U prime is du dt. Then my V is e negative 2t. When you differentiate exponential function, the V prime is rewrite the whole exponential function and differentiate the power of e. That means you differentiate negative 2t, then you'll be getting negative 2. So from here, your dy over dt, it will be uv prime. So means that t minus 1 multiply with negative 2, e negative 2t, then plus v prime, u prime v. So 1 times e negative 2t. Okay, then from here, you may factorize the common term. So the common term is basically the exponential negative 2t. So once I have factorized, I will get e negative 2t. Then this negative 2 will be multiplied to the t minus 1. Then I will be getting negative 2t plus 2. And for the second term, once you have factorized the exponential here, you still have the plus 1. So here, plus 1. Right. So then further simplify, you will be getting e negative 2t multiplied with negative 2t plus 3. So that's the dy over dt. And now lastly, use this chain rule. Okay, this is the chain rule. So chain rule is dy dx equals to dy over dt times dx over dt, or times dt over dx, or you just use a division. It's up to you. So now I will be using the multiplication. So that means dy over dx is dy over dt times dt over dx. So dy over dt is e negative 2t bracket negative 2t plus 3. So now for your information, dt over dx is same as 1 over dx over dt. So now this is our dx over dt. Then when you substitute into this formula, you have to interchange the numerator and denominator, which means I will be getting multiply with t plus 2 over t plus 3. Okay, then now I just need to combine all the terms that will be my dy over dx. So you will be getting these results. Alright, so that's all for the dy dx. Now for part B, find the exact y coordinates of the stationary point of the graph. So whenever you see stationary points means dy over dx equals to 0. Now what you need to do is just refer back to the dy dx in previous part and let this be 0. Okay, so I will just direct copy the dy dx and then you let it be 0. So when the division equals to 0 means that the numerator equals to 0. So when the numerator equals to 0 and numerator has 3 terms here, 1, 2, 3, product of 3 terms equals to 0 means that either one term must be 0 or any one term must be 0. So then we know that exponential will be never 0. So I will write e negative 2t will be never 0. So it means that maybe the negative 2t plus 3 equals to 0 or t plus 2 equals to 0. Okay, then from here, the first one, 2t equals to 3, therefore your t is 3 over 2, or t equals to negative 2. Okay, so but then when you read the question carefully, this is just stationary points, means that one point okay, or 1 y coordinate. But then here we get 2t. So now let's look at the question first. Any condition of the t. So it's given here the t is greater than -2. Right? So you just write given t is greater than -2. That means the t must be just 3/2. So t equals to -2 cannot be accepted. Alright, so now after this, just calculate the y. So substitute the t value into t minus 1 exponential -2t. So from here, I will just write when t equals to when t equals to 3/2, my y is going to be t minus 1 exponential -2t, which means it will be 3/2 minus 1 times exponential -2 times 3/2. So at last, 3/2 minus 1 is half. So I will get half e. -2 times 3/2 is -3. So that is my y coordinate of the stationary point. Okay, so with this, we have completed question 3b. Okay, now question number 4. Let f(x) equals to this function, rational function, express f(x) in partial fractions. So 15 minus 6x divided by 1 plus 2x multiplied with 4 minus x. So first of all, we have to check the highest degree in the numerator of the x is 1. But then for the denominator, when you do expansion, it will be degree 2. Okay, for the x, the highest degree of x in the denominator is 2. Therefore, this is proper rational function. Hence, we can proceed with the partial fractions. So this is going to be 1 plus 2x in the denominator plus with 4 minus x in the denominator. So when the denominator is 1 plus 2x, the numerator is a, and the denominator is 4 minus x, numerator is b. Okay, so from here, we need to get the same denominator as on the left-hand side. Therefore, I will rewrite the term on the left-hand side. Now, I have 1 plus 2x. That means I need to times with 4 minus x to make it to the same denominator. Okay, plus b over 4 minus x. Then I need to times with 4 minus x already given. So I need to times with 1 plus 2x for the second rational function. Then now, by looking at the denominators on the left and right hand side, they are the same now, so we can just ignore them or just cancel them. Then you will just write down the numerators. So 15 minus 6x equals to a multiplied with 4 minus x plus b multiplied with 1 plus 2x. Okay, so now to get the unknowns, right? A very simple method is just let the factors be 0. So now I will let the 4 minus x be 0, which means my x is going to be 4. So when my x equals to 4, my left hand side is 15 minus 6 times 4 equals to, so this whole x minus 4 will be 4 minus x will be 0. Then I will just have to consider the b. So it will be 1 plus 2 bracket 4. So the left hand side is going to be minus 9. Right hand side is 9b. Therefore, the b is minus 1. Okay, now next I will let 1 plus 2x be 0. That means now your x is going to be negative half. So now replace the x values, the x in this equation. Okay, so it will be a negative half. Then for the first term, you will get a bracket 4 minus negative half. So the left hand side, you will be getting 18, and then the right hand side, it will be 9 over 2a. So at last, your a is 4. Okay, so after you have found the a and b, just replace the values in the partial fractions. So now I will get 15 minus 6x over 1 plus 2x multiplied with 4 minus x equals to a is 4, so 4 over 1 plus 2x, and the b is minus 1. Please don't write plus and minus 1 like that. Okay, so because the plus and minus 1 can be simplified into minus, so I will just write the minus in the middle as the final answer. So these are the partial fractions. Okay, so now let's move on to the parts B. Parts B, hence means use the previous answer. Find integration of fx, whereby the x is defined from 1 to 2, giving your answer in ln of a plus a over b, where a and b are integers. So now integrate 1 to 2 fx dx is same as integration from 1 to 2 4 over 1 plus 2x minus 1 over 4 minus x dx. Okay, so from here, I will split it into two integrations. So here is going to be integrate from 1 to 2 over 1 plus 2x 4 dx minus integrate from 1 to 2 1 over 4 minus x dx. Okay, now when you look at the rational function here, especially the denominator, this is basically degree 1. Here 4 minus x also with degree 1. So whenever it is degree 1 in the denominator, right, then you may use the ln formula, which means you integrate f prime x over fx dx, it will be ln fx plus c. So which means now I will substitute, or I will rewrite this f prime x over fx first in my integration. So I will write 1 plus 2x in my denominator. Therefore, my numerator is going to be 2, because differentiate 2x is 2. But then to get back the 4 in the previous step from 2, okay, to get 4 from 2, I need to times another 2 outside the whole integration. Then here minus integrate 4 minus x dx. So when I differentiate 4 minus x is supposed to be minus 1. So then I need to times another minus, because here is positive 1. So I times another minus outside. Okay, then from here it will be 2 ln 1 plus 2x. Then for the second term, be careful with this. Here is minus, another minus. Therefore, it is a plus. Then I will be getting plus ln 4 minus x. And then now consider the limits from 1 to 2. Okay, then now from here, just replace the x by 2 first, and you will be getting 2 ln 5, because 1 plus 2 bracket 2 is 5. Then plus ln 4 minus 2 is 2, and then you minus when the x is 1. So I will get 2 ln 3 plus ln 3. Okay, 4 minus 1 is 3. Now, here, when I simplify, okay, so since you have summation of 2 ln, now we need to apply this formula. Ln A plus ln B equals to ln AB. But then provided both coefficients are 1. Here is 1, this is 1. But then here we get the 2. Therefore, I have to apply another formula. Ln A to the power of B equals to B ln A, which means now, okay, if you want to use the first ln formula, make sure it is 1 ln A plus 1 ln B. Then only you can combine it using products of AB. Otherwise, you cannot proceed. So that's why the 2 here will be moved up to be the degree of 5. So I will be getting ln 5 squared plus ln 2 minus, okay, 2 ln 3 plus ln 3. This is same as 3 ln 3. Okay, 3 ln 3, or probably I can just move up the 2. So it will be 3 ln 3 squared plus ln 3. So since both also summation of 2 ln, it becomes a multiplication. So here is 5 squared is 25, 25 times 2. Okay, and then minus ln 3 squared is 9. Probably here I will just direct write 25. 3 squared is 9. Then because of plus, you times. Then from here, to simplify your answer, okay, look at the answer here. It's just ln of A over B, whereby the A and B are integers. That means you need to apply another formula, because now we are getting minus. So it will be ln A minus B. Ln A minus ln B, it will be ln of A over B. Okay, so now I have to solve the division. So that means this is going to be ln 50 over 9 times 3 is 27. Right, so then 50 over 27, that's the simplest form. That means this will be our final answer. Okay, so let's move on to the next question. Question number 5a. By first expanding tangent of 2 theta plus 2 theta, show that the equation tangent 4 theta is half tangent theta may be expressed as this. Okay, so now tangent 2 theta plus 2 theta. This is to solve using the addition formula. Tangent of A plus B, that will be tangent A plus tangent B divided by 1 minus tangent A tangent B. So in this case, A and B are equal to 2 theta. That means here is going to be tangent 2 theta plus tangent 2 theta over 1 minus tangent 2 theta multiply with tangent 2 theta. So I can simplify this into 2 tangent 2 theta over 1 minus tangent squared 2 theta. Okay, and this is going to be tangent 4 theta. So now we start with this equation. And replace the tangent 4 theta by this expression. Okay, so now I will get tangent 4 theta is 2 tangent 2 theta over 1 minus tangent squared 2 theta. So 2 tangent 2 theta over 1 minus tangent squared 2 theta equals to half tangent theta. But then when you look at the given answer there in the question, okay, you will just see tangent degree 4 1 theta, tangent degree 2 1 theta. Right, it's actually degree 2 of tangent theta, degree 4 of tangent theta. But then for the left hand side, we still have the 2 theta there. Alright, so now you can just check. If tangent 2 theta, that means I will change this to 1 theta, this is 1 theta. So if both 2 theta change to 1 theta, that means this formula, I will just change all my 2 theta into 1 theta. Okay, so that is my tangent 2 theta. Here will be tangent 2 theta. Okay, so now I will get 2, just substitute into this formula by changing the 2 theta into theta. So it will be 2 tangent theta over 1 minus tangent squared theta. That is my numerator. Then over 1 minus tangent squared 2 theta is just square this bracket. So 2 tangent theta over 1 minus tangent squared theta. Then you square it. Okay, then this is going to be half tangent theta. Now, I need to simplify this first. So, the numerator is 4 tangent theta, then over 1 minus tangent squared theta. And the division line, I will just write divide by. Okay, for the denominator, we need to get the same denominator here because this is actually over 1. I want to get it to be 1 minus tangent squared 2 theta. Tangent squared theta, and there's a squared here as well. So I will bring it in the squared. Okay, so therefore, this is 1 minus 2 tangent theta squared over 1 minus tangent squared theta squared. That equals to half tangent theta. Then now, this is going to be 4 tangent theta over 1 minus tangent squared theta. You divide by, get the same denominator. So it will be 1 minus tangent squared theta squared it, and you multiply with the 1 here. Okay, because we want to get the same denominator. That means you will be getting 1 minus tangent squared theta, and you square it. Then you minus, okay, this square, you bring it in. So when you square the 2 tangent theta, it will be 4 tangent theta. Alright, 4 tangent squared theta. Okay, so because of divide, I have to change to times. So when I change to times, then I have to swap. Okay, so means that you have to interchange these two. That means I will be getting 1 minus tangent squared theta squared it, and for the numerator in the previous step, I need to do the expansion for this so that I can simplify. So you have to do the expansion using quadratic expansion, which is a squared minus 2ab plus b squared. Okay, so whereby your a is 1 and the b is tangent squared theta. So which means now here I will be getting 1 minus 2 tangent squared theta plus tangent degree 4 theta. These are the three terms that I obtained when I expand the square of 1 minus tangent squared theta. And don't forget there's a negative 4 tangent squared theta at the back, and then now equals to half tangent theta. Okay, so now you will notice that this term can be simplified, but you still have degree 1 of 1 minus tangent squared theta in the numerator. And then for the denominator, I will try to simplify. So 4 tangent theta multiply with 1 minus tangent squared theta over, okay, when you simplify, you will be getting tangent degree 4 theta. So minus 2 tangent squared minus 4 tangent squared, it will be negative 6 tangent squared theta, then plus 1. And the right hand side, you have the tangent theta. So now the tangent theta will be cancelled off. Okay, and by looking at the answer here, you are given the answer, there's no fraction. That means now my half on the right side should be moved up to the left side, or probably I can just say I times 2 to the whole equation. Then it will be 8, 1 minus tangent squared theta, and this move up. Okay, so the half times 2, it will be 1, then I will be getting tangent degree 4 theta minus 6 tangent squared theta plus 1. Then now just do the expansion for the left hand side. You will get 8 minus 8 tangent squared theta. And then for the right hand side, just rewrite. And now what we need to do for the next step is just to move all the terms on the left side into into right side. That means you will be getting the tangent degree 4 theta as the first term. Then now I will be getting tangent degree 4 theta minus 6 tangent square theta plus 1. So the plus 8 move to right side becomes minus 8. The minus 8 tangent squared move to right side becomes plus 8 tangent squared theta equals to 0. So then you will be getting tangent degree 4 theta minus 6 tangent squared theta plus 8 tangent squared theta. Okay, so when you simplify these two terms, it will be positive 2 tangent squared theta. And then plus 1 minus 8, it will be minus 7 and equals to 0. So now let's check. It is exactly the same. Okay, so shown. Okay, now B, hence means use the previous answer. Solve the equation tangent 4 theta equals to half tangent theta. 4 theta between 0 and 180 degrees. So now we know that tangent 4 theta equals to half tangent theta. It can be expressed as the tangent power 4 theta, okay, or tangent squared theta in a quadratic equation. So it becomes tangent degree 4 theta plus 2 tangent squared theta minus 7 equals to 0. So you can try to factorize this by assuming x equals to tangent squared theta, but unfortunately you cannot factorize this. Okay, therefore, now if you let u equals to tangent squared theta, then x equals to tangent squared theta, this will be x squared and this is x. Okay, but then I don't want to use that, or probably I just use that first. I let x equals to tangent squared theta, then you can see clearly this is a quadratic equation. That means this is going to be x squared plus 2x minus 7 equals to 0. Okay, and then the coefficients will be 1 for the x squared, and then for the x it will be 2, and then the constants will be minus 7. And now for your information, if you are solving the quadratic equation using quadratic formula, the formula is going to be x equals to minus b plus minus square root of b squared minus 4ac over 2a. So then from here, I will write my x is minus 2 because the b is 2 plus minus square root of 2 squared minus 4 times 1 times minus 7 over 2 times 1. Okay, then from here, you will be getting minus 2 plus minus square root of 32 over 2. And you will be getting two values. The first is negative 3.8284 and the next one is 1.8284. Okay, then now we need to solve for the theta. Okay, theta. That means now we have to refer back to x equals to tangent squared theta. So now tangent squared theta is negative 3.8284 or tangent squared theta is 1.8284. So we know that tangent squared cannot be negative. Means that the first one will not give you any solution. So I will just write no solution because it is negative for squared. Okay, for tangent squared. So tangent squared cannot be negative. Now, from here, we have to solve the next value. That means tangent theta is plus minus square root of 1.8284. Hence, you will be getting plus minus 1.3522. Okay, that will be your tangent theta. And now we look at the domain for the theta. The domain is defined from 0 to 180 degrees. And excuse me. And now your tangent theta will be plus minus values. That means it will be in first and second quadrant. First quadrant is when it is positive. Second quadrant when it is negative. Okay, so my basic angle from calculator is 53.5 degrees, which means, okay, first angle is 55.3, second angle is the major angle here, which is labeled as the red color. That means now my theta is 53.5 degrees, and 180 degrees minus 53.5 degrees. Then here is going to be 53.5 degrees and 126.5 degrees. So that's your theta. Okay, so solve for this question. Now, next question, by sketching a suitable pair of graphs, show that the equation has exactly one root in the interval x from 0 to pi. Now, the cotangent, okay, so for the cotangent, we need to refer to tangent. Y equals to tangent x first. So then this is tangent x. Okay, this is the graph for tangent x. But then now, cot half x means that we have to refer to half x, tangent half x. So for tangent half x, it will be just here, half of the graph. That means it's just up to here. Okay, so this is when tangent half x, which means when you label, you still label 2 pi, 0 to 2 pi, which means here is pi. Right? So this is tangent half x. But then when you look at the question, this in the interval 0 to pi, which means I will just do the I will just get the cot half x for this part, 0 to pi. Okay, so which means now my graph is going to be okay. So when you refer to the graph, here is 0, so cot half x is 1 over tangent half x. So when it is 0, 1 over 0 will be infinity. Okay, then here going up to be infinity, so it will tend to 0. Alright, or I would say this is increasing, so 1 over increasing, it will be decreasing. So which means now I will be getting this. Okay, so this is my tangent cot half x. Okay, now the next one is 1 plus e negative x. So for the ex, right, when it is ex, this is the graph. Here is 1. But then when it is e negative x, so e negative x means 1 over ex, means that the increasing one becomes decreasing. So I will be getting this graph. Right, so this is my y equals to e power negative x. And then you are using e negative x plus 1, means that you move up the graph for 1 unit. So when you move up, that means the intersection instead of 1 now becomes 2. Okay, so just move up. So now here I will move up, and at the same time, instead of this graph approaching x-axis, so it will be approaching 1. Okay, because it has been moved up. So it's something like this. So this is your y equals to 1 plus e negative x. So let's say here is 1. Okay, let's say here is 2. So now my graph is going to be like this. So this is my y equals to 1 plus e negative x. Here is my x-axis, 0. Then from the graph, obviously, Okay, there's only one intersection point. So when you are sketching two different graphs on the same diagram and you equate these two equations, that means you are finding the intersection points. So you just write from the graph, there is only one intersection point. Hence, cot half x equals to 1 plus e negative x only has one real root in 0 to pi. Okay, because we are just referring to this interval. Okay, so done for 6a. Now B, verify by calculation that this root lies between 1 and 1.5. So now I will just rewrite the equation. Then by moving all the terms to the left side, I will get cot half x minus 1 minus e negative x equals to 0. And then I will let fx be the whole function. I mean all the terms on the left side. And I'm going to apply the sign change rule. So replace the x by 1 and 1.5. And now when you need to count cot half here, make sure you change the mode to radians. Okay, this one is in radians mode. Then now you will be getting 0.463, which is greater than 0. And then the next calculation is f of 1.5. You will get cot half times 1.5 minus 1 minus e negative 1.5. Then the answer is going to be negative 0.150, which is less than 0. So since now you have two different signs, one is plus, one is minus, then you just write down the conclusion. So there is a sign change. Hence, there's a root between the two values. Okay, so that's all for this part. Now see, use the iterative formula. This is the formula to determine the root correct to 2 decimal places. Give the results of each iteration to 4 decimal places. So x of n plus 1 equals to 2 inverse tangent 1 over 1 plus e negative xn. So now from the previous calculation, we have proven that the x lies between 1 and 1.5. So the initial x can be any values in between 1 and 1.5, or probably can be exactly these two values. So I will just take the middle value of 1 and 1.5, which is 1.25 as my initial value. Okay, so x0 is 1.25. Then you will be getting x1 is 2 inverse tangent 1 over 1 plus e negative 1.25. Then this is going to be 1.3215 because we need 4 decimal places for our working. And final answer is 2 decimal places. Then now, okay, how do we know when to stop? You see here, 2 decimal places for initial value is 25. But then the x1, the first 2 decimal places will be 32. So you cannot stop here because they are not the same 2 decimal places. Therefore, now continue for x2. It will be 2 inverse tangent 1 over 1 plus e negative 1.3215. and then you will be getting 1.3365. And again, they are not the same because x1 you get 32, 1.32. Now you get 1.33. So now continue with x3. Then you will be getting 1.3396. Okay, so by comparing these values with the previous value, now we get the same two decimal places. For the final answer, refer to the latest calculation and the next digit. So if the digit is 5 and above, then you have to round up. Therefore, our x is approximately to be 1.34. So that is the solution for part C. Now, next question, number 7. For the curve shown in the diagram, the normal to the curve at the points P with coordinates xy meets the x-axis at N. That means this is the normal line. Okay, the M is the foot of the perpendicular from P to x-axis. That's why here is 90 degrees. The curve is such that for all x in the interval x between 0 and half pi, the area of the triangle PMN is equal to tangent x. So now, A first part show that mn over y is dy dx. Okay. Now we know that Pn is a normal line. Okay, so m of normal line, let the gradient of let the gradient be m. So I will write m of Pn because this is a gradient of normal. So gradient of normal, your tangent is here. They will be perpendicular to each other. This is your tangent line. So when they are perpendicular to each other means that, let's say this is m1, this is m2, then I will get m1 times m2 is minus 1. Okay? That means now I will write mpn, which is the gradient of tangent, is negative 1 over gradient of tangent, mpn, this is the gradient of normal. It is negative 1 over dy over dx because our dy dx is the gradient of tangent. So from here, your dy dx, okay, I will write, okay, I move up the dy dx, or I will just remain this first. So the gradient of Pn, it will be, alright, how to find this Pn? It will be negative of Pm over Mn, because M is the change in y over change in x. Okay, so the change in y is a Pm, and then the change in x is Mn. But then this is negative because when you look at the slope of this straight line, it is negative. So I will write here negative Pm over Mn equals to negative 1 over dy over dx. So the negative will be cancelled off from both sides. Then the dy dx move up. Okay, and this term move to the other side. So which means your dy over dx is mn over pm. Okay, but then when you refer to the answer here, mn over y. So now your pm, that is the y coordinates. Okay, because at the point m, this is 0. I mean the x is following the x of the p, and then the y is 0. Therefore, that will be just y. So then you can just change this to mn over y. Okay, therefore we have proven this, or we have shown this mn expression. Okay, so we have done for A first part. Now hence show that x and y satisfy the differential equation. Okay, so this one can be solved using the hints. Area of triangle PMN is equal to tangent x. So now area of triangle PMN is tangent x. So when you refer to the triangle here, it will be half of PM, which is our y, times mn. Alright, so it will be half of PM times mn, that it will be tangent x. And the PM is y. Now, what is our mn? Okay, the mn, when you refer to here, okay, so from A first part, dy over dx is mn over y. That means now your mn is going to be y dy over dx. So here I will write y dy over dx. That equals to tangent x. Okay, and now we need to prove this. So left hand side is half y squared dy over dx. Right hand side is the tangent x. So with this, we have shown the differential equation. Okay, now B, given that y equals to 1 when x equals to 0, solve this differential equation to find the equation of the curve expressing y in terms of x. So I will rewrite our differential equation first. To solve this differential equation, we need to apply the separable variables method, which means I keep the y squared dy on the left side, and the half will be moved to right side, becomes 2 tangent x, then dx. And now integrate both sides. Okay, so when you integrate the left hand side, or before I integrate left hand side, just to let you know that to integrate the tangent x is compulsory to change it to sine x over cos x. So integrate y squared, it will be y cubed over 3. And then again to integrate the sine x over cos x, since the cos x with degree 1, we need to use ln. So which means now when I rewrite my integration, which is in this form, I will rewrite the cos x. Differential cos x is minus sine x. Okay, but then my original function was positive sine x, means that I have to times a minus outside, so that my left hand side will be same as previous step. That means this is going to be negative 2 ln cos x, then plus c. So I do not plus c on the left side because both sides also indefinite integral. Therefore, I just write the plus c, the arbitrary constant, on the right hand side. Okay, then now to solve for the c, replace the y by 1 and x by 0. Which means my left hand side is going to be 1 over 3. Then my right hand side is negative 2 ln cos 0 plus c. So cos 0 is 1. This is 1. Then I will be getting 1 over 3 equals to negative 2 ln 1 plus c. And again, ln 1 is 0. Therefore, my c obviously is 1 over 3. Okay, so now substitute this c into the general equation or general solution. Then I will get negative 2 ln cos x plus 1 over 3. But then when you refer to the question, you need to express y in terms of x. Okay, means y degree 1. So first of all, times the whole equation by 3. Then you will be getting y cubed equals to negative 6 ln cos x plus 1. then the y will be, the cube roots of, the degree 3, okay, of the y. To eliminate the degree 3, I will take cube root. So cube roots both sides, it will be cube roots of 1 minus 6 ln cos x. So that is the solution of this question. Okay, now for question number 8. The diagram shows the curve y equals to ln x over x degree 4 and its maximum point M. Find the exact coordinates of M. So when maximum point means that you need to get dy dx equals to 0, which is a stationary point. So which means now we need to differentiate. So obviously to differentiate this, we need to apply the quotient rule. Quotient rule says it is vu prime minus uv prime over v squared, which means now your u is ln x, your u prime is over x, and differential x is 1, because our formula is d over dx ln fx, it will be over fx, then differential fx is f prime x. That means now your fx is x. Okay, and then the v is going to be x degree 4. So your v prime will be 4x cubed. Now, your dy over dx, use the quotient rule here. It will be over v squared, so x degree 4 squared. Then keep the x degree 4, which is the v, and multiply with u prime. U prime is 1 over x. Then minus uv prime. So it will be ln x, then 4x cubed. Okay, so now simplify. So first term, x degree 4 over x. So you can just simplify this into x cubed. Then I will be getting x cubed minus 4x cubed ln x over x degree 8. And now the x cubed is in common in the numerator, so you may factorize it. And then the x cubed and x8 can be simplified. So here will be 1 minus 4 ln x over x degree 5. That is the dy over dx. Okay, and then now you need to find the exact coordinates of the maximum point. So it shows that it has only one stationary point. Therefore, I have to let my dy dx be 0 right now. So dy dx equals to 0 to get the stationary point means that 1 minus 4 ln x equals to 0. Therefore, 4 ln x is 1. Hence, ln x is 1 over 4. Now, to get the x, we have a formula here. E ln a is a. Therefore, you have to take e both sides. That means now I will be getting e ln x equals to e to the power of 1 over 4. So, e ln x is x. Therefore, I'm getting my x coordinate. Okay, once you have found your x coordinate, then just substitute into the y coordinate. So your y is ln x over x degree 4. That means this is going to be ln e 1 over 4 divided by e to the power of 1 over 4, then power 4, which is, okay, now ln e power 4. I have a formula. Ln e power a, it is a ln e. Alright, then ln e is 1, and last it will be a, because this is 1. So which means I will be getting 1 over 4 for my numerator, and divided by this 1 over 4 and the 4, when you simplify, it will be just degree 1. That means e degree 1. So now I will get 1 over 4e, which means you only get one stationary point here because you only found one x. That must be the point M. So my point M with coordinates e to the power of 1 over 4 and 1 over 4e. So that is my solution of this question. Okay, next B, by using integration by parts, show this integration is always less than 1 over 9. So integrate 1 to a ln x over x degree 4 dx. Integration by parts formula is u dv over dx. Dx equals to uv minus integrate v du over dx. Dx, if with limits, just add on the limits over here. Alright, so now we have ln x and x degree 4. So we cannot integrate ln x, but we can differentiate ln x. Obviously, right, this is going to be 1 to a ln x times x degree negative 4 dx. Then I will let my u be ln x because we can differentiate ln x but not to integrate ln x. So this is du dx. It will be over x and 1 in the numerator. Now your dv dx, it should be x power negative 4 according to the formula. One function is u, another function is dv dx. So now your v is to integrate x power negative 4. It will be x power negative 3 over negative 3. So I will simplify this into negative 1 over 3x cubed. Okay, so now the integration by parts formula equals to uv. So uv, so I will write negative 1 over 3x cubed ln x with limits minus integrate from 1 to a v du dx. Okay, so v is negative 1 over 3x cubed. Du dx is 1 over x. Then from here, it's going to be negative 1 over 3a cubed ln a minus negative 1 over 3 ln 1. So the minus and minus becomes plus. So then the x cubed and x becomes x degree 4 in the denominator. And at the same time, the 1 over 3 can be taken out. So I will move up the x degree 4, becomes x degree negative 4. Then from here, for your information, ln 1 is 0. Okay, then I will be getting negative 1 over 3a cubed ln a plus 1 over 3 integrate x power negative 4 becomes x power negative 3 over negative 3. Limits from 1 to a. And then now I will simplify the fraction first. So the 1 over 3 and negative 3 becomes negative 1 over 9. Then the x power negative 3, it will be 1 over x cubed. Okay, so now replace the limits. Replace the x by limits. So I will get 1 over 9, 1 over a cubed minus 1. So then open all the brackets. Okay, or maybe I can just factorize the 1 over 9. So better to factorize 1 over 9 because you need to prove that it is less than 1 over 9. So when I factorize 1 over 9, I will get this first term 1 over 3a cubed. Once you factorize 1 over 9, you will have 3 over a cubed. Three over a cubed ln a. So it means that it will be negative 3 over a cubed ln a. Then this whole 1 over 9 is taken out. Means that you have to multiply this minus to the terms inside the brackets. Then I will get negative 1 over a cubed. Then minus minus is a plus. Okay, so to conclude this, how do we know that it is less than 1 over 9? Now I will get the same denominator. So I make it to all over a cubed. Then that will be negative 3 ln A, negative 1 plus A cubed. Okay, so here I will just write, it will be 1 over 9 A cubed minus 1, then minus 3 ln A over A cubed. Now, let's look at the condition for the A. Your A is more than 1. So when your A is greater than 1, A cubed will be greater than 1 as well. Okay, which means A cubed minus 1 is greater than 0. Now, I have proven that the first term is greater than 0. Now, I need to minus 3 ln A. What happened to the 3 ln A? So 3 ln A will be greater than 3 ln 1 based on A greater than 1. So ln 1 is 0. That means 3 ln A is greater than 0. So here is greater than 0. Okay, therefore, when you consider this whole value inside the bracket, I know that you will get positive minus positive over positive because your A cubed is more than 1, right? Therefore, I will say A cubed minus 1 minus 3 ln A over A cubed will be between 1 and 0. Okay, so when this whole bracket is greater than between 0 and 1, that means this whole, when you multiply with 1 over 9, is definitely less than 1 over 9. Okay, so that's the explanation of this. Okay, so let's move on to next question, number 9. The quadrilateral ABCD is a trapezium in which AB and DC are parallel. With respect to the O, the origin O, you are given 3 position vectors OA, OB, and OC. A, given that this vector DC is 3 vector AB. Find the position vector of D. So now, from here, okay, I will start with DC equals to 3AB. So vector DC is basically OC minus OD. Then vector AB is OB minus OA. And now we need to get OD. So from here, it will be 3OB minus 3OA. That is my OC minus OD. And now I need to get my OD as a subject, means OD move to left side and the rest move to, OD move to right side and the rest move to the left side. And then when I write my OD first, it will be OC minus 3OB plus 3OA. Okay, so now just replace all the OB, OC, and OA. Then you will get 2 minus 3 minus 3. OB is 1, 3, 1. Then OA is negative 1, 2, 3. Because here, negative 1i plus 2j plus 3k. So then, when you simplify all of this, this is going to be 2 minus 3 minus 3. Then 2 minus 9, 3 times 3 is 9, plus 6. Then minus 3 plus 9. So at last, you will be getting minus 4, minus 1, and 3. That is the OD. Okay, now B, state a vector equation for the line through AB. So now I need to know what is the vector AB first. That will be my direction vector. This is OB vector minus OA vector. So my OB is 1, 3, 1. and my OA is minus 1, 2, 3. So when you simplify, you will get 2, 1, negative 2. So the vector equation of the line R, AB is, you can use OA plus TAB, or you may use OB plus TAB. So I will get minus 1, 2, 3 plus T times 2, 1, negative 2. So that is my vector equation of the line. Okay, now B, find the distance between the parallel sides. Sorry, C. Okay, find the distance between the parallel sides and hence find the area of the trapezium. So let's say this is a trapezium because it's mentioned AB and DC are parallel. Okay, so let's say here is AB, this is DC. They are parallel. So now to find the distance between the parallel sides means that you need to know the distance here. Okay, so what to do is I will let P be the point on line DC, which means this is my P. Okay, such that AP is perpendicular to DC. So here is 90 degrees. So now my OP will be following the vector equation of the line DC. Okay, so my OP, or I will write DC equals to OC minus OD first. So my OC is given in the question, 2, 2 minus 3. And my OD already found just now. So you just minus and get the direction vector. It is 2, 2 minus 3 minus 4 minus 1, 3. Then this is going to be 6, 3 minus 6. So my equation, vector equation of the line DC equals to, I just pick the point C, so 2, 2 minus 3 plus, just now I used T, so now I use S, 6, 3 minus 6. So you can leave it in 6, 3 minus 6, or you can just factorize a 6 and, factorize a 3 and leave it in the simplest form, up to you. Okay, so I let P be the points on the line DC, that means my OP is RDC, which is 2 plus 6S, 2 plus 3S, minus 3 minus 6S. Okay, and then from the diagram, from this diagram, we know that AP is perpendicular to DC. That means now I need to get AP dot DC equals to 0. So before that, I need to get what is my vector AP first. So that is the OP minus OA, which means I will be getting 2 plus 6S, 2 plus 3S, minus 3 minus 6S, minus my OA will be minus 1, 2, 3. Okay, so when you simplify, 2 minus minus 1 is 3 plus 6S. 2 minus 2 is 0, so just left 3S. Minus 3 is minus 6, then minus 6S. This is our AP. Okay, don't forget, we need to find what is the distance of the parallel sides, means what is the length of the AP. So now I'm finding vector AP first. So then AP dot DC, okay, is 90 degrees, means AP dot DC equals to 0. So I will get 3 plus 6s, 3s, minus 6s, dot DC, already found just now, 6, 3 minus 6. Then now you need to multiply. And plus with the next multiplication. Okay, so expand all the terms. 18 plus 36s plus 9s plus 36 plus 36s equals to 0. So from here, 36s plus 9s plus 36s, you will be getting 81s. Then the 18 and 36 you plus together, it will be 54. So when you move the 54 to right side, becomes negative 54. Hence your s is negative 54 over 81. Then you will get negative 2 over 3. Okay, then now I need to get my AP. So my vector AP is just to substitute, okay, the s value. That means I will get 3 plus 6 times negative 2 over 3, then 3 times negative 2 over 3, and then lastly negative 6 minus 6 times negative 2 over 3. So when you simplify, this is going to be negative 1, negative 2, and negative 3. Sorry, and negative 2. Okay, so the distance is magnitude of AP. That is square root of negative 1 squared plus negative 2 squared plus negative 2 squared. So this is 3 units. Alright, so done for the first part. And then now, enhance, find the area of the trapezium. So area of trapezium, let's say, this is A, here is B, the distance is C. So the area is half of A plus B times C. That is the area of trapezium, which means now I need to find length of AB, length of DC, and multiply with length of AP. So now the length of AB, refer back to the previous part. We have found the vector AB here, so 2, 1, negative 2. That means the length is going to be square root of 2 squared plus 1 squared plus negative 2 squared. So that is 3. Then now next is to find the length of DC. So DC vector is here, 6, 3 minus 6. So length of DC square root of 6 square plus 3 square plus negative 6 square. That means you will be getting 9. Okay, therefore area of trapezium it will be half of the length of AP, which is a vertical distance, multiplied with summation of the two parallel sides. Then I will get half times 3 times 3 plus 9. So this is going to be 18. So that's the area of the trapezium. Okay, now question 10. Verify that minus 1 plus root 2i is a root of the equation. So I need to replace the z by -1 plus root 2i, because root means the z value. So here, when it is degree 4, okay, so I will say that it is square of square. So it will be, you expand this first using the square, then you will be getting a square plus 2ab plus b squared. Then I will square another one. So I will square outside. That will be degree 4. Okay. So this is going to be -1 minus 2 root 2i minus 2. Because I square is -1. Don't forget. Alright. I square is -1. Then you have a square plus 3 bracket. So this is going to be 1 minus 2 root 2i, then minus 2. And do expansion. So I'll get -2 plus 2 square root 2i plus 12. And now for the first one, I will simplify. -1 minus 2 is -1 minus 2 is going to be, okay, wait, this is not -1, because when you square of -1, it will be +1. So I will get 1 minus 2, which is -1, then minus 2 root 2i, and then you square it. And this 3, you can move in. But then, of course, this 1 and -2, it will be -1. Okay, so I will write plus 3 minus 1 minus 2 root 2i. Then minus 2, and the 12, it will be +10. Okay, and now expand again, then you will get 1 plus 4 square root 2i minus 8. Then do expansion, minus 3 minus 6 root 2i plus 2 root 2i plus 10. So here, when you simplify, look at the terms. 4 root 2i plus 2 root 2i is 6 root 2i. Then you minus 6, that means it's 0. Okay, then followed by 1 plus 10 is 11. Then you minus 8 minus 3, that means it's 0. Okay, so once you have proven that it is 0 here, that means -1 plus square root 2i is a root of the equation. So we have completed 10a. Now the next part, find the other roots of this equation. So when -1 plus square root 2i is a root for the equation with real coefficients, see, real coefficients, right? That means by default, the conjugate will be another root. So -1 minus 2i, -1 minus square root 2i is also a root of the equation. Now, I need to get the factors, okay, the multiplication of the factors for these two roots first. So it will be always variable, which is a z minus the root times by the z minus another root. That will be the factors. These two are the factors. So now I need to simplify. Okay, so just do expansion. It will be z squared minus -1 minus root 2i z minus, so just do expansion like this, then -1 plus root 2i z plus, okay, so when you expand the -1 plus root 2i and -1 minus root 2i, Right, minus 1 plus root 2i times minus 1 minus root 2i. This one we can simplify using a plus bi times by a minus bi is going to be a squared plus b squared. Okay, so here I will simplify using this later on. Then now when you do expansion, z squared, it will be plus z plus 2, no, square root 2 zi. Then here do expansion and together with the z at the back, so plus z minus square root 2 zi, and the last two terms when you multiply together, it will be a squared plus b squared, so plus a squared plus b squared. Okay, so from here I will simplify. These two terms will be cancelled off. Then it will be z squared plus z. So minus 1 square plus square root 2 squared, that means that is 1 plus 2. Then I will be getting plus 3. Okay, the z and z, 2z. Okay, that will be my products of two factors. And then now since you need to find other roots, means that you need to find another 2z value. Then now I need to get it from the polynomial division. So I will continue here. Z squared plus 2z plus 3, then your polynomial is, now when you look at the polynomial over here, it is z degree 4 plus 3z squared plus 2z plus 12 equals to 0. There's no z cube, so I will add on the term with coefficient of 0. So it will be plus 0 z cubed plus 3z squared plus 2z plus 12. Okay, so to get z degree 4 from z squared, you must times with z squared. So it will be z degree 4 plus 2z cubed plus 3z squared. So then, when you minus, first term will be 0. Second term is negative 2z cubed. Third term will be 0. Bring down the plus 2z, and when you need to get negative 2z cubed from z squared, you have to times with negative 2z. So here is going to be negative 2z cubed. Negative 2z times positive 2z will be negative 4z squared. Negative 2z times positive 3, negative 6z. And again minus. So first term will be 0. Second term here is 0 minus 4z squared, means that is 4z squared. Then 2z minus 6z is plus 8z. Bring down the 12. Okay, so now we must get 0 remainder. Means that now to get 4z squared from z squared, you need to multiply with plus 4. Then you will be getting the same term, all the same terms. So which means, okay, z degree 4 plus 3z squared plus 2z plus 12 equals to z squared plus 2z plus 3, which is our divisor over here, times with the quotient. Alright, and I let this be 0 because we are solving equals to 0. So what I need to do is I just solve this part because we have found the roots from the first factor. So z squared minus 2z plus 4 equals to 0. And then this quadratic cannot be factorized. Therefore, my a is 1, my b will be negative 2, c is positive 4, and use the quadratic formula to solve this. It will be z equals to minus b plus minus square root of b squared minus 4ac over 2a. Then this is going to be 2 plus minus square root, square of negative 2 is 4. 4 minus 16, it will be square root of negative 12 over 2. So 12 is 4 times 3. Okay, 12 is 4 times 3. So when you take the square root, it will be same as square root 4 times square root 3, which is 2 square root 3. But we have a negative, so square root of negative 1 is I. That means I will be getting complex roots. So it will be 2 plus minus 2 square root 3i divided by 2. Then that will be 1 plus minus square root 3i. Okay, so my other roots, so the other roots will be, just now you were given negative 1 plus square root 2 I. That means my first other roots will be negative 1 negative square root 2i. And then followed by these two complex roots. It will be 1 plus root 3i followed by 1 minus root 3i. So this is the solution of this part. Okay, so we have come to the end of the video. Thank you for watching. I hope you have enjoyed this video. Please subscribe to the channel and recommend it to your friends. And also stay tuned for more upcoming videos. Thank you. Bye.